So as we saw in the video, when we are comparing and ordering decimals, we want to stack them. I'm going to share my screen so you can see what the journal note looks like, if it will allow me to. There we go. Sorry for that delay. And when I do that, we're going to see this journal that you guys already have in your file. I am enlarging it to 100%, so it's a little bit more legible. And I'm going to view it as a full screen. This is so that students in the classroom can actually see what I'm doing. So here it talks about how we can use a place value chart. So if we are comparing 28 and 674 thousandths and 28 and 634 thousandths, we would line them up in the place value chart. When we find a number in a place value that is not the same, we can actually start the comparison. As you saw in the video, if the tens are the same, they're equal. If the ones are the same, they are equal. Tenths are the same, they are equal. So we begin with our hundredths. We have a 7 and we have a 3. So when we look at 700ths versus 300ths, 700ths is greater than 300ths. Therefore, 28 and 674 thousandths would be greater than 28 and 634 thousandths. And we write that with the greater than symbol. The arrow will always point to the lesser number. So as you can see, the arrow is pointing towards 28 and 634 thousandths. If we wanted to flip that around, we could say that 28 and 634 thousandths is less than 28 and 674 thousandths. So if they have the same number of digits, line them up in a place value chart so that you can compare them easily. And you'll hear Ms. Hodges refer to this quite frequently as stacking them up. If they have a different number of digits, for example, 7 and 108 thousandths is being compared to 7 and 22 hundredths, you would still be able to stack them up, but you'll add a 0 at the back end so that both numbers have digits in the thousandths place. That just makes it easier to do the comparison when we have the same number of digits in the stack. Again, our ones here are equal. Our tenths, however, are not. So we would actually compare the 1/10 and the 2/10. 1/10 is less than 2/10. So 7 and 108 thousandths is actually less than 7 and 22 hundredths. Or again, flipping that around, 7 and 22 hundredths is greater than 7 and 108 thousandths. Again, we want to stack them because students quite frequently get confused and think that because one has 3 digits following the decimal and the other number has 2 digits following the decimal, that it is automatically greater. And that is not always the case. Our next example is seeing how we compare decimals on a number line. So in 4th grade, you used number lines for comparing and ordering whole numbers. And in 5th grade, we can use the number line to compare decimals. So on this number line, we have 0 and we go all the way to 1. So you can assume that each tick mark is a tenth. 1/10 is basically 0.1. And it can also be considered as 10 hundredths, which is 0.10. Okay, so that is how you have all of these numbers here involved. So with the bottom number, you have 1 72 hundredths. So you are looking at 1 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, and between 7/10 and 8/10 is going to be your 72 hundredths. Again, remember that 7/10 is also 70 hundredths. 8/10 is also 80 hundredths. So if you make your mark at 1 72 hundredths, then do the same thing for 1 67 hundredths. It's going to be between 1.6 or 1 6/10 and 1.7 or 1 7/10. Again, those are also, put a 0 at the back end, 1 60 hundredths, 1 70 hundredths. So then they have marked 1.8, which is 1 8/10. So again, if each tick mark is worth a tenth, you have 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, and 8/10. In doing that, you can easily see that 1 67 hundredths is less than 1 72 hundredths. That is less than 1 8/10. So we could actually write this out as 1 67 hundredths is less than 1 72 hundredths, which is also less than 1 8/10. If we needed to flip that around, we could flip it to 1 8/10 is greater than 1 72 hundredths, which is also greater than 1 67 hundredths. So this is a good visualization of how to compare decimals on a number line. In our next example, we have, again, several numbers now to compare, and it is asking a question, which of the following numbers is between 19 and 2 hundredths and 19 and 204 thousandths? So they give us three options: 19 and 222 thousandths, 19 and 2 thousandths, 19 and 22 thousandths. So again, if we use that place value chart and we stack them, we can compare our numbers, and we see that 19 and 22 hundredths is between 19 and 2 hundredths and 19 and 204 thousandths, because 19 and 22 thousandths is less than 19 and 204 thousandths. And again, it gives you a little explanation that 0/10 is less than 2/10. Obviously, we know that, but it is greater than 19 and 2 hundredths because 204 thousandths is greater than 22 thousandths. Again, 200 is much greater than 0.22, which is what we see here. And the final example, we have no pictures. We have just the decimals, so we get to decide if we want to use a number line or a place value chart to compare them. Here they give you the problem, how it would be read, ask you to write a statement comparing the length of worm A and the length of worm B. So you would either stack them on a place value chart or draw them out on a number line to do your comparison. Finally, giving you the answer of either the length of worm A is greater than the length of worm B, or the length of worm A is greater than the length of worm B. Notice all we did was change from wording to symbol. You could also say the length of worm B is less than the length of worm A, or the length of worm B is less than the length of worm A. Simply because 8.49 or 8 and 49 hundredths is greater than 8 and 409 thousandths, because this 0 right here in the middle is less than this 9 right here at the end. Again, we would see that very clearly, either stacking them in a place value chart or placing them on a number line. And finally, at the end of your journal page, I have provided for you the anchor charts that we have here in the classroom. This anchor chart is all encompassing, and it shows us what models of decimals might look like, decimals and fractions. So I just did a model of the tenths and a model of the hundredths, and also how we would read them. So for example, in the tenths, if we have 4 tenths shaded out of 10 total, then we have 4 over 10, which is 4 tenths, or we have 0.4, which is also equal to 4 tenths. That is also equal to 40 out of 100, so 40 hundredths. Meaning if we didn't have a tens model and we had a hundredths model, then 40 of these would be shaded instead of these 4 out of 10. So you can basically imagine these 10 lines going up and down, creating 10 columns, and then 10 rows going across to create a grid that is 10 by 10 or 100 cubes. Again, that part is a review of 4th grade material that you should have learned in the first semester in 4th grade. But we always want to circle back to that so that we can refresh our memories. Same thing with hundredths. Here you're going to have 10 columns and 10 rows to create 100 boxes or cubes. If we shade 54 of those boxes, then we have 54 out of 100 or 54 hundredths shaded. This is its representation as a fraction. This is its representation as a decimal. And of course, here's the word version of that. When we have a whole number involved, we create a mixed number in fractions. But in our models, that means we have a 10 by 10 grid completely shaded for one whole. And we have another 10 by 10 grid that only has 64 out of 100 boxes shaded, giving you 1 and 64 100ths, which is equal to the decimal 1.64, read out loud as 1 and 64 hundredths. In our decimals, we know that a decimal is a number that uses place value and a decimal point to show a value less than 1. It does not mean that we won't have values over 1, but anything behind a decimal represents a part. When you are dealing with decimals in tenths and hundredths, the easiest way to think about that is thinking of money. So if we did not have the 7 here, we could look at the tens, the ones, the tenths, and the hundredths and think of money, and that would be $13.04. But as this decimal reads, we are looking at 13 and, that decimal is always read as an and, 47 thousandths, okay? Adding and subtracting decimals was hit heavy in 4th grade. You had models and you also had decimals where you had to learn how to get that additional number in, just like we saw when we were putting them into a place value chart to compare them. So I won't go heavily into that. But comparing and ordering decimals, again, I have put it in my own little place value chart. I have stacked them all to compare them. 3 is the greatest number, but I've been asked to put these in order from least to greatest. So from least to greatest, I'm obviously going to start with 0 ones. There is only one number that starts with 0 1, so that is my least number or my first number in listing them least to greatest. Then I've got 2 numbers that have a whole number of 1. So I'm going to go on over to the tenths column and I'm going to compare 3 and 6. Well, 3 is less than 6. So 1 30/100ths is going to be my next digit in my list. 1 67/100ths will be my third number in my list. And of course, 3 whole with no tenths or hundredths is just 3. But to keep the stack, we added those zeros. Notice here it was given to us as 3, but in the stack we add the decimal and the 2 zeros so that we have the same number of digits. And listing them in order from least to greatest, we have 52/100ths, 1 30/100ths, 1 67/100ths, and of course, 3. I hope this helps you with your journal and your notes today. If you are virtual, all you need to do is keep this in your Google Drive for reference. If you can print it, you can glue it into your journal for reference. But if you cannot print it, it will save to your Google Drive and you can download that for reference at any time.